Welcome to Chapter 6, Manual Software QA Testing, a crash course. Let's recap what manual QA testing is. Manual software QA testing is the process of testing an application to ensure that it meets its expected requirements and its core functionality to identify any bugs or defects using manual methods of validation for workflows. This type of testing is required when the application involves complex data or input, requiring human judgment or analysis, such as determining the usability of an interface. In the field of software quality assurance testing, you'll often hear the term application under test. So, what is an application under test, or AUT? An application under test is simply the software application or system that is being tested to ensure that it's high quality and bug or defect free. The AUT is the focus of the testing effort, and various testing techniques such as functional testing, performance testing, security testing, and other types of testing to validate its functionality, reliability, and security are in place. Let's discuss the Manual QA Testing Lifecycle. The Manual QA Testing Lifecycle is the approach for testing a system under development before release manually in both functional and non-functional ways to ensure that it meets expected requirements as well as it's bug-free or defect-free. The manual QA testing lifecycle involves various stages, such as testing requirements, test planning and design, test environment setup, test execution, test results analysis, and reporting or closure. Under the umbrella of manual software QA testing, there are two main types, functional and non-functional manual testing. Functional software QA testing ensures that the software application or system is high quality and bug-free, with core features and functionality working as designed. The most common types of functional manual software QA testing are unit testing, integration testing, smoke testing, regression testing, and user acceptance testing, among many others performed today. Non-functional manual testing focuses on aspects of the software application or system such as performance, reliability, security, scalability, and usability under different circumstances. Some of the most common types of non-functional manual software QA testing are performance testing, reliability testing, scalability testing, security testing, and compatibility testing performed today. One of the most common types of testing, black box, where the tester focuses on without knowing the internal code or architecture testing by providing results as an end user that may be present in the software. Let's look at an example. The list first to create and manage to-do areas of functionality and user input form. The tester wants to perform black box testing. testing for the list-first mobile application to focus on actions such as editing existing items and deleting or changing completed as inputs. Another very common technique or approach in manual testing is white box testing. White box testing is the exact opposite of black box testing, meaning that it does focus on the functionality of the software, but now with knowing the internal workings, meaning that the tester knows the source code and architecture of the software, how it's designed, and how it works. The tester performs white box testing by conducting static and dynamic analysis of the source code, the actual programming languages and code, as well as complex algorithms to identify any defects or bugs that may be present in the software code, not just the software, its functionality itself. In this case, for white box testing, the tester needs to be very technically capable. Let's look at an example scenario of white box testing. The tester wants to perform white box testing on the list-first mobile application to create and manage to-do lists, which, as discussed before, consists of three main areas or functionality: the login page, user dashboard, and user input form for new items. Here, we look at unit testing and code coverage as sub-techniques or methods of white box testing. As part of the white box testing process, the tester can use unit testing to ensure that the login page code handles user input with validation and sends data to the database, as well as performs code coverage testing to estimate how much code in percentage-wise has been inspected and reported for quality. When we speak of handling the user input with validation, think of something like an email address, where the form or validation is that you need to have an @ and you need to have a domain like Gmail or yahoo.com at the end of the email. Else, it will throw an error or exception. Another very critical method or process in manual testing is smoke testing or sanity testing. Smoke testing is a type of software testing that is used to check whether the critical major functionalities of a software application or system are working or not. Basically, it's kind of a pulse check or health check. Sanity testing is a type of software testing that ensures the software meets the specified requirements and is logically and technically acceptable for further testing, especially when considering things like integration with more advanced and other components. Let's look at an example of smoke or sanity testing. In the scenario with the list-first mobile application, once it's released, the tester can perform smoke testing by trying to install and launch the application on their phone. Also by checking the login functionality and creating, editing, or deleting the to-do list items to verify no bugs, unusual behavior, or defects are present. As the latest version of the list-first mobile application is released, the tester can perform sanity testing by checking the requirements and ensuring the basic core functionalities of the system or application are working as expected, to verify no new bugs or defects are introduced into the existing system. One of the most important types of testing under the manual testing umbrella is unit testing. Unit testing is a type of software testing where individual units or components of the software are tested in isolation from the rest of the system, basically in smaller pieces. The purpose of unit testing is to verify that each unit or subunit of a system is working correctly and meets functional and performance requirements. Let's look at an example scenario for unit testing. Gizmo is an e-commerce website that sells children's clothing, and the development team is integrating a new enhanced shopping cart feature or experience and decides on doing unit testing to ensure expected functionality. As part of Gizmo's unit testing lifecycle, the tester focuses on core functionality of the cart, things like adding items, removing an item, updating items, quantity, and calculating the total price are all tested individually as components within units, basically as their own individual test case scenarios independently. System testing is a type of manual testing that verifies the behavior and functionality of an entire integrated software system as a whole. Basically, as the software system has many moving parts, it evaluates its compliance with specific requirements, meeting its intended purpose, testing all components, subsystems, and interfaces to verify that they all work together seamlessly with desired results. Let's look at an example of system testing in a scenario where we're working with an online banking application. Gold Bank is a large provider that is developing a new system for making it easier for customers to access and manage their financial accounts. So the development team is performing or thinking of performing system testing. Once the development of individual components, such as the login system, user account management system, and transaction processing system is complete, they perform system testing to ensure that the entire system, all three systems, are integrated together and work as expected seamlessly. Integration testing is a very important manual testing technique or type that verifies the interfaces and interactions between different software components or modules work together as expected. Integration testing helps to identify any interface or communication errors, data flow issues, or other problems that may have been missed or overlooked during unit testing to ensure quality. Let's look at a sample scenario of integration testing. Before releasing the Gizmo e-commerce mobile application, the development team performs integration testing to test several modules, such as a product catalog, shopping cart, payment gateway, and customer account management. The integration testing would involve integration between the product catalog and shopping cart, integration between shopping cart and payment gateway, integration between the shopping cart and other systems or subsystems, such as the delivery system. Basically, you have several different systems and subsystems that work together or are integrated to work seamlessly for the application to function as a whole. Usability testing. Usability testing is a type of software manual testing that measures how user-friendly and easy to use a software system or application is to anybody or any end user. It involves evaluating the software system or application from the perspective of end users with the goal of identifying any usability issues or design flaws that may affect the user experience. Let's look at an example scenario of usability testing. The development team is asked to build a mobile application for a retail company that allows customers to browse products, place orders, and track their deliveries to ensure that the app is providing a good user experience. They conduct a usability test to gather feedback from a group of end users. This feedback is usually collected through surveys and other types of interactions with the end users. Usability testing was performed through tasks like asking the end users to perform browsing and searching for a specific product, adding a product to the shopping cart and placing an order, tracking the delivery status of an order, providing feedback on the user experience and design of the application. User acceptance testing, UAT. User acceptance testing is a type of manual software testing that is conducted to ensure that a system or application meets the needs and requirements of the end users. UAT is usually performed by a team of end users or stakeholders who use the system or application to validate its functionality, usability, and compatibility. Let's look at an example scenario of a user acceptance testing, or UAT. The user acceptance testing team for an e-commerce website is asked to test through performing various tasks, such as searching for products, adding items to their shopping cart, checking out, and providing feedback on their experience. As part of the UAT testing, the team gives feedback on the layout to determine whether or not it's easier to use. And for example, the checkout process being intuitive, as well as reporting any errors or bugs or unusual behavior that's encountered. Regression testing. Regression testing is a type of manual software testing that's performed to ensure that the changes or updates to a system or software application don't negatively impact the existing functionality of the system in any way. This involves retesting the software to verify that previously working features and functions have not been affected by the changes made to the code. Let's look at an example scenario of regression testing. When a software system or application is updated with new features or bug fixes, the testing team will usually perform a full suite of tests to verify that the software is functioning correctly as designed, and also that all the existing features are still working as expected, like before. When a new feature is added to a shopping cart application, the regression testing will verify that the new feature works correctly without affecting the existing functionality of the application, such as adding items to the cart or calculating prices or even a checkout process. Regression testing would ensure that these functionalities for this shopping cart or e-commerce application are not broken in any way after implementing something new or adding a new feature. Sometimes you may hear of something known as ad hoc testing. Ad hoc testing is a type of manual software testing that's performed without a concrete or formal plan or test case. It's more impromptu, and it's performed by a tester based on experience and intuition, as well as their level of knowledge within the project or application. The tester during ad hoc testing performs things like exploring the software system and trying out different actions or user inputs that may uncover issues such as bugs or defects. Ad hoc testing is also known as on-the-fly testing. So basically, there really isn't any formal process for it, but it's kind of something that the tester determines themselves to see how it can be tested in different ways. Let's look at an example of ad hoc testing, a scenario in which a software tester who is exploring a new application tries different actions or inputs to see how the system responds, such as in entering invalid data into a form to see if the system can handle it correctly, or they may click on different buttons or links to test the navigation and user interface. The tester can then report any issues or bugs they find to the development team, who can then address them before the software is released to the end users. In this ad hoc testing scenario, the tester is using unconventional methods that are not really as part of the design for the testing process. They're kind of testing as they go. As you now know, throughout this course, the software testing lifecycle is basically an approach or process used to test something. The first stage or phase of the process is to identify the problem or the problem statement. The second phase or stage in the process is to analyze the problem and design a solution for the problem. Once the analysis and design is complete, then comes the last stage of the process, which is execution. Once the execution is complete and the data and results are recorded, then we move on to the successful reporting of the software delivery cycle. This is basically a very high level and easy approach to understanding how to think like a software tester. Let's look at a sample test scenario for a software testing process. Here we have a bicycle. So the first question you want to ask in this process to identify the problem of how to test this product is, how many possible ways are there to test a bicycle? And I mean a physical bicycle just like this one. So some of the general questions that come to mind are the brakes, the wheels, the handlebars, and the seat. So then we convert those questions or ideas into actual analysis and design as part of our solution. Once we solidify these ideas, we look at things such as adjusting the height of the seat, steering direction of the handlebars, brake pedals, and even the tire pressure of the wheels. Then we have questions like, does the bike stop with brake pedals? Which is one test. Another test would be to see if the bike needs any air pressure or additional air to function normally, as well as can you ride the bike normally? Is it slanted or is there any issues? And something like, can you adjust the seat height of the bike for the user? So these are all examples of functional or manual system testing and how we can actually think like a manual software tester and test a bicycle. Let's look at another sample test scenario for a software testing approach. This time, we're testing a desk fan. So the first question that comes to mind is, how many possible ways are there to test a desk fan? Some things such as AC, DC, wiring, the speeds and availability or options for the buttons on the fan, the rotation option to ensure the buttons are working correctly, and that the fan is responsive to the input or buttons that you click on the fan itself. So some of the functional or manual system testing scenarios that come to mind or tests that come to mind for this situation would be things like, is the fan battery operated or electric, needing a wired plug-in? Does it have variable speed options or buttons such as slow, medium, or high? Does it connect to an AC or DC outlet? And is the settings such as slow, medium, fast correct? Does it actually operate that way, or is it kind of, having an issue? As well as the rotation manual or automatic option, basically setting it to manual or automatic based on the user input or preference. Let's look at another sample software testing scenario. This time, we're going to look into how we can test a physical pair of headphones. So the problem statement, as always, is to see how many possible ways are there to test our headphones. Some of the ideas for testing that come to mind are something like turning the headphone system on or off, controlling the volume by pressing up and down, is it Bluetooth enabled, as well as does it require charging or is it a plug-in, or is it a wired or connected headphone? Some of the functional manual system testing and usability ideas for test scenarios would include things such as device compatibility and connectivity with other devices, having a Bluetooth feature, learning or attempting to control the system volume settings by pressing up and down, turning on the device on and off. Does it actually need charging and how does it charge? How comfortable is it on different ear sizes, from small, medium, or large ears? And is it wireless or wired option, which is very important because wireless headphones and wired options have different types of settings and different types of tests in this scenario. Thank you.